Hi all, Dmitry is here and welcome to my next video about AA battery testing. In previous time when I tried to test ever active batteries, alkaline and rechargeable ones, my test setup has failed and actually I did not finish that test, and after that I decided to make a new testing setup. You can watch separate video about how it's made and what it can do. And today I will finish the test that I not finished previously. I have new pack of ActivEnergy alkalines. I have new ActivEnergy rechargeables. It's ready to use, so it's recharged and likely low discharge ones. And you can see this is a red mark on minus pole, and I have some rechargeables from previous test, so we will compare this one rechargeables with this. So is there something changed, or maybe it's actually the same, and let's compare them with normal alkalines. So let's start with alkalines. Okay, alkaline battery is installed, and at this time I will not film every battery change, so for you it will be like I installed just one battery and conducted all three current tests with three different currents, but I guess changing every battery is just boring. So let's start with alkaline. 700 millivolt and voltage and 100 milliamps discharge current. Let's go. And as you can see, current started to flow, so setup works. And by the way, interesting moment here is this alkalines is made in EU, European Union. It's made in Belgium, and this one's made in China. So for some reason alkalines is made in European Union, but rechargeables are still China. This is quite interesting. So let's give it some time to test. Okay, so we finished with normal alkalines, ActivEnergy alkalines. Data is collected, and let's take a look at the raw results.
So here is the raw data for the ActivEnergy alkalines, and what we can see here is when we increase the current, the voltage begins to drop quicker and quicker. So here you have number of counts, and as you can see, with 0.5 amp it falls really quickly. And another interesting moment is graphs of power and capacity. As you can see here, they almost linear, and power goes higher than capacity. So because voltage is higher than 1 volt, we got more power than capacity. But with increasing the current, we see that power curve is like bended, and resulting power is falling really quickly. Internal resistances is just for the whole picture, but you should take a look only at 0.1 amp, sorry, because I'm not sure if here we have correct values, because it's strange, but with increasing the current we got lower and lower internal resistances. I guess this because a way how my devices measures it. So yeah, we should take a look at only low current internal resistance.
So let's go to the next one. Let's start with ActivEnergy ready to use. First I will test them like off the shelf, like they have with the state like they have now, and let's check how many energy we have in them just when we buy them in the store, how ready to use or not they are. Okay, data collection for the ActivEnergy pre-charged ready to use batteries is complete, and you can take a look at the raw data.
Here is the raw data for rechargeables, pre-charged ones, ready-to-use ones, like them off the shelf. Interesting moments here is maybe this very beginning of the graphs, because as you can see, voltage almost from the start it's on steady level, so there is no quick drop, almost no quick drop at the start. But in general, all seems to be good here.
And while I charging that pre-charged ready-to-use cells for the next test, let's take a look what do we have in normal rechargeables, maybe old one. I charged them few days ago, so they are not new, but I almost not used them, so we can count on getting fair results. Yes, we cannot get amount of energy that was on the shelf like we did with pre-charged ones, but we at least can estimate capacity, internal resistance and all other characteristics. So let's go. So we finished the test with ActivEnergy normal rechargeable, not ready to use. And while you looking at the raw results, I will test this ready to use ones. It will be last test in this video. I will check how they perform after recharging.
Here is raw data for ActivEnergy rechargeables, and as you can see, slopes of voltage is almost horizontal. Even with increasing current, almost nothing changes. It just discharges faster, but no changes in shapes, which is good.
So let's do last test in this video. Let's check what do we have here in this ActivEnergy ready-to-use ones. I recharged them, so it's a situation like in normal usage, not like when you just buy them in the store. Let's take a look what do they have. So last test is finished. We got all data for ActivEnergy. Let's take a look at the raw results for pre-charged ready-to-use ones after recharging, and let's compare all of them. Let's take a look what do we have.
The last tests raw data, rechargeables ready to use after I recharged them. So after first test I recharged them, and here we have raw data after freshly charged. And as you can see, form of beginning of graph slightly changed, so we have this longer path before voltage will be stabilized, but in general almost the same. And finally we got all the data. Let's take a look what do we have with ActivEnergy batteries. So first let's take a look at the capacity graphs. It's capacity is most common measured thing, so if you will take a look at some other battery comparisons, you probably will only have capacity and nothing more. And what do we have here? First interesting moment is actually even at low current 0.5 amp, alkaline capacity is slightly lower than rechargeables. This is quite interesting, because normally alkalines, as I thought before, normally alkalines have bigger capacity than average rechargeables, but they cannot deliver high currents. And really, yes, with increasing the current we have bigger drop of the capacity in almost 2 times, from almost 2000 milliamp hours to 1000 for the alkalines. But for the rechargeables, yes, we see slight capacity drop, but actually not much. So as we can see here, from the capacity point of view, rechargeables are better than alkaline. And let's take a look at the energy, because actually our devices consuming energy, not just the capacity. So normally our devices, even especially if we have digital devices, when voltage will be dropped, they will increase current because of internal regulators, because they need energy, not capacity. So what do we have here? We have even faster drop of the energy for the alkaline, almost 2 and 5 times drop. So with increasing current, energy that it can actually delivers really faster dropping really fast, sorry. So actually it seems like we can only use alkalines for remote controls, for maybe really not powerful LED flashlights, but for something powerful, for toys, for example, for remote controllers, for for remote controllers, for video games, especially ones with force feedback. We will need rechargeables, because with high current, alkaline will die really quickly. What do we have with rechargeables? Surprisingly, pre-charged and ready to use and normal rechargeables are slightly different. And as you can see here, this red graphs is rechargeables pre-charged as they was on the shelf. So after long storage, we have some capacity, energy drop, but actually not much. So they can store the charge for prolonged period. I don't know how long they was in the store on the shelf, but I think 1 or 2 months as minimum. So this drop actually seems good to me. Looks like they can be used as substitute to alkalines. And yes, we have some difference between rechargeables pre-charge, ready to use, and normal ones. Ready to use are slightly better. So I think yes, we have some differences actually, and this is interesting. I firstly thought maybe it's just same battery but with different markings, but looks like no. And the last but not least interesting moment is internal resistance of these cells. As you can see, this internal resistance is a thing that not really correlates with the state of charge, because at least for rechargeables, for alkalines it correlates with state of charge, and for rechargeables, as you can see, we have almost the same internal resistance for ready-to-use ones as they was on the shelf and as they was after recharging. Normal rechargeables have slightly bigger internal resistance, and alkaline have much more internal resistance. What does it mean? What is it for after all? This means that in device with high current drain, like digital camera, for example, or some digital device, maybe some IoT sensor that sleeps for most of the time, but for a short period it has current bursts. In that moments when we have high current, even if alkaline have enough capacity to run the device for prolonged time, because of higher internal resistance, we will have voltage drop and device will shut off. So, for example, your digital camera can say that, okay, battery is drained, I will not work anymore. And you take that batteries from the digital camera, and they will work in flashlight, for example, or with some toy train, and they will work for some time. Why? Because they not drain it fully. They cannot deliver high current in short words. So that's it. Thank you for watching. I hope it was not so boring like it was before. So I hope my new setup is more informative and videos became more interesting. Please please write in the comments your opinions. your thoughts. Do you like this or not? Maybe you have some suggestions about the format. Anyway, thank you for watching and have a nice day. Bye.